Okay, welcome to Eccentric Molded Engineering's 2017 webinar series. If you are here for design considerations to successfully manufacture complex overmolds, then you're in the right spot. We welcome both customers and future customers to learning about how to successfully design your overmolded project. My name is Brian Graves, and I will be your host for this session. Just a few things to cover before I turn it over to our keynote speaker. This presentation is expected to last approximately 15 to 20 minutes. Afterward, we will hold a short question and answer session based on the questions you've submitted. And so during the presentation, feel free to submit your questions using the chat function located in the lower right of the control panel. We'll have time just to answer a few of those questions. And if we run out of time before all questions are answered, we'll follow up by sending you an email containing those answers, as well as a link to the recorded version of this webinar for future reference. And with that, I'd like to turn this webinar over to our keynote speaker, John Sidorowitz.
Welcome, everybody. Appreciate you taking time out of your day to join us. My name is John Sidorowitz. I am the Vice President of Inside Sales and Technical Support here at Eccentric Mold. I've got 15 years of injection molding experience, seen thousands upon thousands of parts in design and come across my desk. And overmold is probably the most common and where we see the most issues. So we want to take what I've learned and what we've learned over the years and other projects. I'm going to share that with you guys today. And let's get started. So we'll quickly go over the agenda. First, what is overmolding? Two, we'll go over some overmold examples, some complex, not so straightforward overmolds. Material evaluation, feature specifications, surface finishes for both the substrates and overmolds, and then file preparation for quoting. So what is overmolding? Overmolding is taking a substrate or a first shot and then taking a second shot, which is typically a rubber or another plastic, and overmolding that to that first shot, thus creating assembly, as you see on the far right there. So we'll go over 3 examples of complex overmolds. There are many more, probably 20 plus. We're just going to kind of highlight on probably the 3 that are most popular. The connecting of 2 or more substrates. So taking 2 or more parts and creating assembly, eliminating a assembly function, or creating a sealing surface, replacing a gasket, something like that. The next would be a cosmetic or aesthetic detail. So kind of make a part pop, just provide different color contrast like we see in the sample there for the example, the black with the red. And then lastly, a tactile function. So you're changing the touch or feel of the part. This is going to be like a grip or a button. The parts actually on the bottom right actually apply to all 3 of these examples. We'll touch on this. This is a good overmold example. So this was a successful design. The customer needed to have a actuating button, which is the red part you see there, overmolded onto the housing, which is the green part. So the blue area is the actual overmold, the TPE or the rubber that we overmolded. And you can see a nice consistent wall thickness, nominal wall. We had good adhesion. And with this part, we actually had to tunnel the gate underneath the part and do a sub-gate into that area because it couldn't be done from the opposite side. So in this case, this is a bad overmold example. So we've got thick to thin wall sections. This is a big no-no in injection molding, period. In having that, you're going to get problem with flow, filling, especially in those thin wall sections. And if it does fill, you have to take into account peeling because we're not going to get the adhesion that we're looking for. And in this case, the customer did put mechanical locks on the thicker section versus the thin section. So we weren't going to get the adhesion what we were looking for. So we had them have to account for the spacing of the overmold flow, which is that thin section, to open that up to allow material to flow better. So what we did, we talked the customer through making some changes. So what they did was created a nominal wall throughout the thickness for the overmold. They made the wall thickness meet the required specs for that material, and then created mechanical locks throughout that to ensure a good bond mechanically and chemically. So now we'll kind of touch on the design considerations when doing overmolds. So we'll look at material evaluation, feature specifications, the different surface finishes you should look for when designing, and then lastly, file preparation. So first and foremost, with overmolding, it is critical as the design is, so is your material selection. You need to do the homework on your materials. Utilize resources on the internet. You can use us, but the best resource is probably going to be the material suppliers. Utilize the data sheets that you can find online. Not only for your substrate material, but your overmold material. For substrate materials, there's probably hundreds of materials that you can use. The most common ones are going to be, your ABS, PC-ABS, polycarbonates, and some nylons. These are going to be materials that provide good bond or adhesion for the overmold. The materials you're going to want to stay away from are materials like polypropylene, your polyethylenes, low density, high density, and your acetyls. The reason for this is they've got a natural lubricity in them. So, for example, if you're trying to glue something to a wet surface, it's just not going to work. It's not going to stick. So if you try overmolding a rubber material to one of these materials, it's just going to peel off, and you're not going to have the desired result. So try to stay away from these materials. So on your second shot, your overmold, typically you're probably going to be looking at some type of rubber. And in some cases, it could be another hard substrate, as I mentioned previous, like an ABS or a polycarbonate. But, pay attention to those materials. Again, utilize the data sheets. You want to focus on, does this material have good adhesion to my substrate material? What are my minimum wall thickness requirements for this material? Another thing to look for is if you're looking for a tactile function for this material, you want a soft feel. You want to look at the durometer versus the flexural modulus. Just because it's a soft material or a softer durometer doesn't mean it's going to have a soft feel, so that's what you want to pay attention to as well. But just do your homework on your material, just as it's as important, or if not more important, than your design. Feature specifications. Wall thickness again. Having a nominal wall thickness to promote good flow throughout the tool. Making a good part and meeting those minimum requirements for that material thickness. Having a consistent wall thickness, but it's too thin for that material in order for it to flow, it's not going to produce a good result. We're going to get short shotting, we're going to get shut off or freeze off. It's just not good. So just make sure you're meeting those requirements for that overmold material. Radii. The best thing I can say is treat your overmold part as a separate part from the substrate. And design it in a way to promote good flow, add rads where you can. Try to avoid, tight corners, 90-degree corners, like hard drops, anything like that. Example, trying to run, water through pipes at 90-degree angles, you're just not going to get good flow in that corner. So with a nice rounded radiated corner, material is going to flow great through that tool. Subgating and gate locations, that's one thing you got to think about when designing your overmold. How are we going to gate this part? Where's material going to flow in? How are we going to get material to the areas that have the overmold? So in the one instance that we showed, we gated through the bottom of the part into the area. So subgating is an option. You can gate through mechanical hold, as you see on the right there in the middle picture. So just try to think about your part in reverse and how you're going to get materials using flow channels, how you're going to feed that material to those areas. Because if you have overmolds in separate areas and there's no way to get to them, it's going to be difficult. So just pay attention to that and how we would gate and fill those parts. And your shutoffs is another big thing. You want to make sure you have good, clean, hard shutoffs to avoid flashing and peeling. So there's use of, you can use accent grooves or hard shutoffs. We've got some examples on the right there. Just gives you a cleaner part, minimizes the flash, especially on rubber parts, the way the material flows. If you can't get a nice clean shutoff, you're going to experience some flash and peeling of the overmold. Oops, excuse me. So, sorry about that. Surface finishes. So we'll kind of touch on substrates, then go into the overmold. So on your substrates, your surface finish doesn't really matter for the most part. Typically on your substrates, you can do a B3 finish or even a blast, but doing a blast will actually create more surface area for your overmold material to bond to. So it doesn't hurt to apply a blast. But when you're talking overmold materials, especially rubbers, TPE, TPV, TPUs, you want to stay away from polishes. You're going to get, you're going to see sticking in the mold, and the end result isn't going to be what you think. It's not going to come out looking like a polished lens or anything like that. Keeping to a B3 or a light blast, you'll probably achieve the same look as if you polish the mold. So, and on top of that, it's going to keep integrity of your part when during the molding process. On a little side note, we've got an image there. It's a texture plaque that we have in process that we're going to be sending out. So if you guys are interested in receiving one of these texture plaques, just reach out to us, give us a call, send us an email, and where to send it, and we'll get you on the list to get those. And they'll be made in different materials, so you can actually see, how surface finishes look on different materials. So give you a good idea there. Last is file preparation. When we quote, we need to kind of review the project as a whole and individually. So what we like to see is one assembly file of the part as you see it designed, how you want to see it in your hand, with separate bodies, and then separate the files as well. So if we're talking a simple part, substrate overmold, we would need the substrate and overmold parts as well. So we'll kind of touch base on, we'll go over the summary. And again, if you guys got questions, make sure you submit them in the bottom right corner of the screen here, and we'll get to those here in a minute or two. Again, biggest thing, evaluate your materials. Check your data sheets, do your research, make sure the two materials you're looking to overmold are compatible and they're going to work together. That's key. 2, treat your overmold as a separate part. Design that overmold as a separate entity of that overmold. Try to follow all the rules of injection molding design. Nominal wall thickness is critical. Meeting the required wall thickness for the material chosen. RADs, designing flow channels, mechanical holds where you can. Just making sure there's a way to get material where you need to for your overmolds. Using hard shutoffs or accent grooves to prevent flash and peel. Surface finishes. Try to stay away from polishes, especially on your overmold parts when using rubbers. It's just going to prevent sticking. It's going to be a better part, keep the integrity of the part. And lastly, the files. Again, in order for us to quote, we're going to need 3 separate files, one the assembly and then the individual files for the overmolding. And again, if your questions aren't answered today, or if you have any more after this, feel free to give us a call. You know, we're here to help, and we'd love to talk to you about your project. And lastly, design it as you dream it, or design it as you see it in your head. You know, don't design the part so watered down that you know it can be made. You know, with the right manufacturer, you know, we can make it come to life. So, you know, design it, talk to us. We can go through it and let you know what can be done, and go from there. But yeah, just don't design it down. So with that being said,
thank you very much, John.
Thank you.
It was a good overview. We have some questions that have come in. Here's an interesting one. Is it usually pretty easy to get adhesion information from plastic sheets between different combinations of polymers? Thanks for that, David.
Well, Prospector is a good source for data sheets, ideas.com, IDES.com. There's a lot of overmold materials out there. If you're talking rubber materials, a lot of them will specifically say what the materials would adhere to. You know, it'll say good bonding for, you know, PBTs, nylons, and, you know, it'll list out the materials that they have good adhesion to, but that's not always the case. So the best thing would probably be to contact the materials house, and they'll let you know if it's a good material for overmolding.
Okay. Here's another one that's coming in. Can you overmold clear PC and get optically clear results, both in finish and clarity in the lens?
That's a really good question. I'm assuming just overmolding kind of a clear window or a light pipe into another part. I have one project that comes to mind where we overmolded an actual clear window and a set of light pipes into a nylon part. So we had two substrates, which were the two clear lenses, the lens and the light pipe, and it was overmolded by a nylon, and they were optically clear still. So you have to pay attention to your temperatures too. So you can't have a overmold that's going to be hotter and melt the substrate material. That's where you got to kind of pay attention to your materials. But yes, it can be done.
Oh, great. There's one more question. For gating, is the core side the most common for the gate location? Are there situations where you cannot gate from the core side?
Most common, no. It's all going to really depend on your design and if you can have a gate vestige, or where you can have a gate vestige. There is going to be some instances, very rare, where we cannot core or cannot gate from the core side. But if there's a way, we will find a way.
Okay.
And again, it just comes down to design.
All right, we have time for one more, and I think this is a good one. That
one we kind of touched on.
Well,
there's one right there.
Oh, multiple. There we go. Can you have multiple substrates in the overmold?
Yes. So as long as there's a way to overmold them all, yeah. I mean, we've done, 3 or 4 overmolds. Sometimes it can take 2 overmolds to get 4. You can.
Okay.
Let's see what else you got here.
Here's a question I can answer. Do you record the webinar to have access later? Yes, of course. Everybody who has registered for this webinar will get a link to the recording. So yes. And I think that'll about do it. I'd like to thank you for joining the webinar here at Eccentric Mold and Engineering. If you have any questions or interests in our products, please visit our website, our social channels. You can find us on Facebook, Twitter, LinkedIn, or contact us directly at the number which I'm going to put up here, or the email listed there as well. And again, a recorded version of this webinar will be sent to all registrars within 48 hours. And with that, I'd like to thank you, and we'll be signing off in 3, 2, 1.